Hello, this is a list of nodes which we are going to discover along this lesson. We will also use the nodes that we are already familiar with from past lessons. As we already know a lot of nodes, we will try to do something more interesting. Okay, let's get started. First, we need a grid. Let's hide the shelf as well as the playbar. Then double-click and dive inside. Put a 100 for rows and for columns. Now let's create a mountain node just to make some noise on the grid. I will adjust only the element size and height. Let's create also a mesh node to make some kind of irregularity in terms of topology. Put a 0.03 for target size. Let's also create a sphere. Put a 0.1 for scale. Look, the sphere type is a primitive. It means the sphere has only one point. Let's go on. Now we need the attribute VOP. Connect the mesh node to the first input, the sphere to the second input. Template the sphere, then jump into the attribute VOP. Now I want to introduce you to a new node called the import point attribute. The import point attribute can fetch the attribute value from the specified geometry. I want to import the point position of the sphere. Since the sphere is already connected to the second input, we must connect the second string port to the file. Well, now we need to specify the point number, the position of which we are going to import. Since the sphere has only one point, the number will be 0. And finally, we must provide the name of the attribute we are going to import. The default is p, what we need. Let's create a distance node, which we already know from the last lesson. I want to get the distance for each grid point from the sphere. Connect to both positions. Now let's visualize the distance values as a caller. For that we need the setVector component node. Connect the distance to the float value. Select the first component of the vector, which is red. Connect the output vector to CD port. Here we go, we got a visualization of the distance attribute for each point. Let's jump up the object level. Select the sphere and move it. As you can see, points that are close to the sphere tend to black because the distance values are close to 0. Okay, let's dive into attribute VOP again. Now I want to show you the alternative to visualize any attribute. First, let's delete this one. Then hold the X key and click to this port. That's it, Houdini automatically creates a visualize node, which essentially does the same thing. If necessary, we can bypass this node. You can also create this node yourself. Okay, let's go on. Now I want to invert the distance attribute. For that, let's drop down the complement node. I also want to fit it. Let's adjust the source max and source min. Something like this. Now I want to show you two very important nodes. The first one is a bind. The second one is a bind export. The bind node simply imports any type of attribute that already is attached to the geometry. The bind export simply writes a new attribute in the geometry. In fact, these two nodes are one single node. The differences between them are these two activated checkboxes and the export specification. Now let's delete the bind node and leave only bind export because I'm going to write the distance as a new attribute. Connect the distance to the bind export. Give it a name. I will call it a mask. Now let's switch to a geometry spreadsheet. And here it is. The newly created attribute can be checked in another way. Hold middle click on the attribute VOP and here it is. Okay, let's dive inside again. Now I want to push up the geometry with this mask. Let's create a getVector component. Connect position to it. Then extract the Y component. Let's also create a setVector component. Select the Y component. Connect position to it. Then connect the Y component. And the output vector goes to P. Now we can edit the extracted Y component. For that, let's create an add node. Wire to this line. Let's hold down the Control key to hierarchically move the add node to the right side to make room for further work. Now let's add the mask to the Y component. Here we go. We push up the geometry in Y direction with a mask. Let's bypass the visualize node to make it more noticeable. Definitely it is too much. We can multiply the mask by some value to adjust as we need it. That's it, we can control the mask's influence. I will leave this value at 0.1. Okay, now let's jump at the object level. Let's give a name to this attribute VOP. Let's go on. Now I want to create a copy to points node. Plug the deformed grid to the second input as target points. Now I want to create a sphere and connect to the first input as a geometry to copy. We copied the sphere onto these points. Let's also scale down the sphere. I also want to change the shading mode. Now let's create the second attribute VOP. Wire to this line. Give it a name. Then dive into it. Now I want to create a p-scale attribute, which is simply a uniform scaling factor. The copy to points node knows about the p-scale attribute. Let's create a bind expert node. Call it p-scale. Then create a constant. As you noticed, our spheres are gone because now their uniform scale factor is 0. Let's tweak the constant value. Here we go, the spheres are scaling up and down. Let's put a 0.2 for now. I want to temporarily give them some color. Just right-click on CD port, select the constant. Then set a 1 for the green channel. Now the spheres are more noticeable. Okay, now I want to randomize the p-scale value. For that, let's create a random node. This operator generates a random number based on the position in different dimensions. Let's connect the ptnum to the random input. The ptnum gives us the number of each point in the current geometry. Look, the random node generates random values in range from 0 to 1 based on point numbers. Let's multiply the p-scale by these random values. As you noticed, now we have a random p-scale. In order to contrast a random range between 0 to 1, let's add a power node. So, we made a contrast between the smallest and biggest p-scale. Let's also clamp the smallest values. Like so. Now I want to add a noise to p-scale. Let's create a turbulent noise. Give him a position. Then create an add node and add the noise to the p-scale. Let's adjust the noise settings. Looks like good. I also want to increase the initial p-scale. That's it. Now I want to multiply the p-scale values by the mask which we created recently. Let's create a bind node and import the mask. We have to write the correct name of the attribute and specify the type. Let's multiply the p-scale by the mask. Take a look, the spheres disappeared in areas where the mask value is 0. Now I want to fit the range of the mask. Let's play with a new range and see what it looks like. Okay, it seems good. Let's jump to the object level and check it all in action. Just select the sphere and move it. Here we go, moving the sphere the mask moves, which in turn drive p-scale. Let's move on. Now let's create one more attribute VOP. This time we will set up the color. First let's create a random node. Plug the point number. In this menu select the 3D color output. Then plug the output vector to the CD port. As you can see, now we have a random color for each sphere. We can uncheck this option. In order to change the seed of randomly generated color, we have to shift the point numbers. That's it, for each value is generated a new color. Now I want to create a color in the specified palette. First let's delete this connection. From this menu select 1D output, this means now the random node generates random numbers in range from 0 to 1. Let's also create a ramp parameter node. Plug the random values to it. The output goes to the CD port. Let's jump at the object level and set up the desired color range. Okay, it's good for me, let's go ahead. Now I want to import the mask attribute, then change the color where the mask is greater than 0. Let's create a bind node and bring into the mask attribute. Let's check the mask visualizing it. Now let's edit the mask a bit. For that let's create a selling node. This operator returns the smallest integer, greater than or equal to the argument. Wire it. Look, all values that are greater than 0 turned into 1 because the 1 is the largest integer in this range. There are two more similar nodes that also do rounding, but each in a different way. Now I will show you the second one, which is called floor. This operator returns the largest integer less than or equal to the argument. Let's create the third, called round to integer. This operator rounds the argument to the closest integer. Let's also connect the mask to these two nodes. Now I want to compare the result of these three nodes. For that let's create a switch node. Connect all them to the switch. The output of the switch goes here. Now we see the result of selling. Let's switch to the second one, that is the floor. This time all values that are less than 1 turn to 0 because the 0 is the smallest integer in this range, so now we only have a few red spheres whose values were 1. Let's see the result of the third version. The round to integer node returns the nearest integer value. In our case, the values that are greater than 0.5 become 1 and values less than 0.5 become 0. We will use only the selling node, so let's get rid of these nodes. Now let's create a two-way switch node. This operator takes an integer input. If this input value satisfies the condition parameter, the output is set equal to the first input value. If the integer input does not satisfy the condition parameter, the output is set equal to the second input value. This provides a simple way to switch between two values and simulate an if-then-else construct. Let's set a condition based on the mask. First, let's convert the mask to the integer value because the condition port of the two-way switch node is also integer. Let's connect the mask to the condition. Then plug the ramp color to the second input, which will set the color for spheres that don't satisfy this condition. Connect the output to the CD port. Here we go, where the condition is satisfied, the color of the spheres become black because we still have not specified the color when the condition is true. Let's arrange these nodes just to organize them. Now let's create one more color ramp. Connect the mask. Let's rename the ramp because this name already exists. Connect this ramp to the first input of the two-way switch node. Great, we just have to set the ramp colors. Okay, that's good for me. Let's see how it looks in action. Looks good, but I want to tweak the p-scale attribute a bit. Let's test it again. And finally, I want to adjust the mask range. That's it, let's check again. Here we go, now everything suits me. Okay, that's all for this lesson. We will continue to discover new nodes in the next lesson.